Welcome. Today I'll be talking on series versus parallel circuits, so we can understand the difference in very simple terms. So first, what is an electrical circuit? An electrical circuit is a closed loop through which electric current flows from the positive terminal to the negative terminal. As you can see, here is a positive terminal, here is a negative terminal. Once current flows through, goes through a load and comes back, that is a closed loop. So this is an electrical circuit. The next is series circuit. Now, in a series circuit, components are connected end to end, as you can see in this diagram, and in this case there's only one path for current to flow. Current just flows through the load. So basically that's the characteristics of a series circuit. So let's go to some key points. The same current flows through all the components. In the case of series circuits, the voltage is divided across the components, and if one component fails, the entire circuit stops working. So this is an example. We have a 12-volt battery. We have L1, L2, and L3 connected end to end. In this case, if L1 gets bad, L2 and L3 are going to stop working. If L2 gets bad, L1 and L3 are going to also stop working. And same goes for L3. And in a parallel circuit, components are connected across multiple parts. As you can see here, the components are not connected end to end. They are connected individually. So positive goes to positive, negative goes to negative individually. So in this case, if L1 is bad, current will still flow to L2 and L3. If L3 is bad, current will still flow to L1 and L2. So in the case of parallel circuit, there are multiple paths for current to flow. Parallel circuit, the voltage is same across all components. The current is divided among the branches, and if one component fails, the others keep working. And we are going to have a little comparison between series and parallel circuits. Path for current: series has just one path, parallel has multiple paths. Now current, the same current flows in all components. In case of series, parallel, it is divided among the branches. For voltage, the voltage is divided across different components in series, and in the case of parallel, the voltage is the same. And failure of one component in the series stops the entire circuit, while failure in one component in parallel stops only that component or only that branch. And a basic application is series circuits are mostly used for decoration lights and Christmas lights, while parallel we use them in our homes and all of that. So the most important thing for you to know is that parallel circuits, the voltage is the same but the current is different. Series circuit, current is the same, voltage different. So that is it. And again, in a case of series, if one component get bad, the entire circuit stops working. But in the case of parallel, if one component get bad, only that component stops working. Like I said before, in case of application, decoration lights, series, parallel circuit is how our homes are wired. Our bulbs and our sockets, that's how they are wired. And why are houses wired in parallel? First is safety. If one appliance has a problem, others still work fine. Reliability, light stays on even if one fails. And again, we need to have independence, because each appliance is supposed to work independently. One appliance is not supposed to depend on another. And again, convenience. Imagine you live in a house where there are 4 rooms, and all those 4 lamps in those rooms are all connected in series, which in this case means if one lamp gets bad, all the other rooms are going to go dark. Or let's say all the lamps are connected in series and we have just one switch. In case someone in room 2 wants to turn on the light is going to go on in all other rooms. And if someone in room 4 wants to turn off the light is going to go off in all other rooms. So that is not very, very convenient. So like we said, key takeaways: series current has just one path, while parallel current has multiple paths. That's why our homes are wired in parallel circuits. Thank you very much for watching this video. If you found this video very helpful, please support by liking, sharing, and subscribing. Thank you very much for your support. I appreciate it.